Hello everyone and welcome in this video where I talk a little bit about my research to make a little drawing application inside my own game. So originally I took a free asset that did that, and I was not happy with a bunch of limitations it had, and also about its performance, which was actually pretty bad. And so I started changing the code bits by bits and eventually threw it all away and started making my own thing. And I was pretty happy about it. So the first idea I had was, well, every update I'm going to check where the mouse is and I'm going to draw on a texture a circle, a disk that has a certain radius and a certain color. And this is what it looked like. Now you can see there's a little bit of a problem. Is if I move slowly, no problem. If I move faster, well, since on the two different updates the mouse will have moved quite significantly, well, I'm just drawing two disks and I need to fill in whatever is in the middle. So I did some research, and after searching a little bit, I found an algorithm that's called Bresenham's algorithm that plots a line from coordinates x0, y0 to x1, y1. And then it has a delegate. Well, it didn't have that, but I added this function so I could actually give it anything I want. It's just going to do something for every pixel between two coordinates. What it is up to me to define. And actually, this ended up being very useful. So let's see. Now I have an implementation of several brushes. And so the first thing I did was to just see if it worked. So let's see that in action. We're going to plot the line here, and we are going to see what happens. And as you can see, so I call the plot line, and then I pass it my own paint pixel method that will paint a pixel. And that will actually check if the pixel can be painted and all that kind of stuff. So now that that is changed, let's see it in action and see if it still works the way it should. So right now, okay, it still works like that. And if I move fast, you can see there's a line that's being drawn here. So, but of course, the line is not the right radius. So how do I get an extra radius? Well, amongst other implementations of the Bresenham's algorithm, I found one that had a plot line width algorithm that took actually a width. So it's the width of the line. I have a radius on my circle. So the way I do this now is to pass on, where is it? So we're going to remove this and change this line. We're going to pass on twice the radius because this is going to be the thickness. And then there's an anti-aliasing settings, whatever. And I pass it my paint pixel method again. And let's see what that looks like. Let's go into Unity and wait for Unity to recompile. And I really thought, oh, great, that's the answer to my problem. Well, as you can see, come on. Don't be so laggy, Unity. Hopefully I didn't kind of double click on this. Oh, no. Okay, let's click. So as you can see, it kind of works, but it does a bunch of weird stuff, right? It doesn't really work. Like if I draw a horizontal line, like the dots, it's really not how I expect it to be. So this was not satisfying. I had to find another solution. So I thought, what the heck? I'm just going to draw a disk at every point along the line. So that's where this delegate is pretty useful, because now I can just call plot line, and at every pixel of the line, instead of drawing a single pixel, I'm going to paint a full disk. Let's see what that does. Now let's see how it works. And once again, Unity needs to recompile. Well, Unity needs to re-import the compiled scripts. And let's press play. Okay. Wow. That looks nice, right? That's exactly what we want. Isn't it great? Now, if I move really fast, you can see that drawing those discs is a little taxing on the performance. Now, this is still fine, right? Because it's supposed to be played on a tablet, and I mean, kids are not going to move their fingers that fast. And if they do, well, whatever. But if I change the radius here to be 100, no, let's actually just do 50 because 100 is going to be way too much. 500, no way. And let's change the color to white. And as you can see, it is actually very laggy. So that's not a good answer. That's not a good solution. We need to find something else. So I went back to the drawing board. I tried to find some algorithms and I could not find what I wanted. So I started thinking about this myself and imagining where can I let's draw, delete all that. Okay, so let's imagine this is here our, I'm going to do this in black for clarity. So let's take a black here. This here is our origin circle, and this here is our destination circle. Come on, right? So we don't know really what the direction is and whatever, but we can once again do a plot line thing from the center to the center. And then if I take this thing and if I take a line that's perpendicular to this thing here, and I try to figure out where the perpendicular lands on the circle, I can kind of draw a line like this. And then I can memorize this pattern. That was my idea anyways. I can memorize this pattern and then copy it again and again. But the problem is that it didn't work like this. Because I was thinking, yeah, I can just put it there and I put it there. Yes, but I needed to follow the line. So if I follow the line, look what happens. This here is actually going to be just next to this, so it's going to look like this. But this one is a 1 pixel higher. So if I do this now, look what happens. I actually start getting white little dots here. And so this is normal because I'm skipping this thing here. But let's see it in action. Let's see that version in action, see what it looks like. And so this one is a little bit more involved because I have to first calculate the pattern, so the line that I showed to you, and then apply that pattern to every point along the plotted line. That was the idea anyways. And so, did I disable the rest? Yes, okay. And so if I do this, come on, it takes a little bit of time. Let's start this. Come on, Unity, you can do it. Okay. So now let's see. Hey, look at this. We indeed do get those funny little patterns. Now this looks cool, but what about performance now? What about the performance? If I move very quickly, I still have that. I still have those angles. I mean, there's not much you can do about it, but they're still fine. But what about now I change the radius to 50? Well, this still looks good, right? It's still pretty fluid. It's still pretty good. I could turn on the stats here. So I have 270 FPS. If I move around, I go down to 82 FPS. So It's still okay. Let's go to 200 now and check what happens now. With 200, of course, the FPS should really drop. But that's no surprise. Okay, so this kind of works, but not really as well as we'd hoped. And so I had to think of something else. So I went back to the drawing board and thought, okay, what I could think about is making, you know, how we have this line here. Let's draw it in blue this time, just to show it a little bit better. So we have this line here, right, that we had. Well, we could also have this same line here, and then we could actually draw a rectangle with some kind of a rectangle that goes between those 2 points. And if we could fill this rectangle, then we'd be fine, right? So I thought about it for a while. I saw some algorithms that allows you to check, you know, there were actually lots of polygon filling algorithms, but I was thinking that there were a bunch of things that those polygon algorithms were checking that is just not necessary for my rectangle. And so I came up with this idea that you actually have 2 extreme points here. This one is the lowest point on Y, and this one is the highest point on Y. And then we can look at this line here that we draw, and we can keep all the points on this line that we draw that are for a given Y on the farthest on the left. So let's look at this here. These are the farthest points on the left for a given Y value. And we can do the same for all the points that are on the right. These are the farthest points that are on the right of this line. And then, once I have all those points, all I need to do is to draw lines to fill the pixels from the leftmost X value to the rightmost X value. And so that's what I did with another algorithm here. All I did was define what the 4 corners of my rectangle are by calculating the bounds, and then I plot a line in the right order. If you don't do it in the right order, it's not going to work. But I plot lines on all the 4 corners to create that rectangle. And for each pixel of that line, I'm going to see if I can add it to my left-right table. I call it like that. So I have an add left-right table element thing here that just looks for a given Y value. If we already have a min-max value for X, if we don't, then we just create a new one. If we do, then we check if the current value for X is smaller than min Y or bigger than max Y, and we update the table thus. And then finally, when we want to paint this table, all we have to do is to basically just say, just take every Y value and paint from one X to the other incrementally. And so once that's done, yeah, just need to say has changed equals paint LR table canvas. There you go. And so I have an init and a paint has changed equals paint LR table. Y value assigned is not used in any execution path. Why? Has changed. Has changed or equals. By the way, or equals. This is just to know if I need to repaint the canvas. So has changed or equals paint LR table. And once that's done, let's look at it in action. Did I press play? I don't think I did. There we go. And look at this. Now there are still a few little problems here due to the way I calculate my bounds, I think. I could keep working on this, but it's still a lot better than what I had before. And it kind of works. I mean, it's with the radius of 10, it doesn't look too good. But if you go up to a radius of 50, this problem kind of goes away. So with bigger radius, you still have a couple of little artifacts, but it's fine. And look at the FPS. It's still pretty close. I mean, we're at 92. It's still pretty close to the FPS that we were having with the previous method. So I'm rather happy about this. And let's go with 200 now. Not 2000. 2000 is going to be very slow. And let's go there. And we just go really hard. And I don't see a huge difference between the previous method, which was actually not drawing that many pixels. So I'm very satisfied. I think it's a lot more optimal than what I had before, and it was really interesting to try and figure this thing out. And I'm really happy that I did. Had lots of fun doing it. So this is it. Hope you like this, and see you next time.